Okay, sound check, testing, 1, 2, 3, 1, 2, 3. Okay, hello everyone, good evening. Welcome to our SFU Starry Nights for the month of September. I think this is the first one in the entire month. My name is Rohit, and I'm joined here with my co-host Zina. While we get everything set up, we will do a quick sound check as well, just to make sure everyone is able to hear us. So yeah, take it away, Zina. It's on to you. Yeah, I think you're correct. The last time, yeah, I think the last time we had something like that was probably in August. We were very hopeful to do a Starry Nights last week, but then, or sorry, 2 weeks ago, um, or even last week, I remember. But obviously, with the rain, it just kind of washed it all away. Um, and while we're waiting for everyone to join in, we do have some moderators in the chat as well. So for today, we'll be joined by Kyle, Zach, and Disha, who is from the Royal Astronomical Society of Canada. So some old faces and some new faces. So welcome everyone. And I know and I think Zena and I, we both know that we're a bit early today, but that's okay. This was a good opportunity to make sure everything is working, so we get the ball rolling in for our Starry Nights. Absolutely. And then yes, and I mean, of course, I was having some technical difficulties this afternoon while trying to set up everything up, and then obviously with the weather, that was the other unknown, because sometimes with the weather, it's gonna get cloudy or it may get cloudy, but I think we're looking okay, I believe. It's gonna be hopefully a good night for stargazing. Yes, Zena and I, we came across some new targets this time around. So hopefully the weather cooperates and with the cloud cover as well. So it'll definitely be a fun and exciting time. While everyone is kind of trickling down to the stream, just is our audio clear? For everyone in the chat box, if anyone can just kind of type a message and say if the audio is good or not. Oh, and we have Haley as well. So hi, Haley. Okay, so yeah, we're all good to go. We're all clear. Okay, perfect. So yeah, Zena, why don't you take it away? Why don't you start us off? What's the first thing we're gonna look at today? Oh, okay. So we're gonna switch it up this time around. Okay, yes, I do like that idea. While while we're obviously, going through the targets that we want to look at, the other thing also is to keep an eye out on the weather. So yeah, Zina, I'm in favor of that. I mean, if we're good to go, then we can try. Then we can definitely try a one of the nebulas. Is that something that you wanted to try first? Okay. 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 Oh, okay. So just to the moderators as well, are you guys only hearing my voice and not oh, no, looks like Zena, we can't hear you. Okay, just give me a second. Let me just see what's happening with this one. Okay, just give me 1 second while we kind of figure out the technical aspects. No, you're not muted on my side. Okay, just give me one. Mm-hmm. Yeah, I've done that too, and that should be working. Okay.
She said you can't. She can't hear me.
Okay. So I've just tried something now. Does that let's see, does that work? Can we hear Zena now? Zena, if you wanna just do another sound check.
Hello, everyone. Can you hear me? Oh, we can hear.
Okay, did that
Not for
work?
me. Can you hear me? Perfect.
Okay, I think that fixed it
You
out.
did it, Rohit.
Yeah,
You did it.
I'm so sorry about that, Zena. I'm not sure what happened, but
It's okay. Technology has never been on my side. It's always been against me. I don't know why. I haven't figured that out yet. So
that was I
took a
guess
while.
that I guess that was part of the technical issues that you were having earlier today as well. So we'll just
I know, right?
we'll just associate it with that.
Oh,
So yes, so what Dean and I we were just discussing earlier, and I'm really sorry again, we kind of missed that part. Is um, we'll actually this time around because of again as I mentioned we're keeping an eye out on the weather as well. We want to make sure we can get to the targets that we have in mind. So based on that, Zena would like to switch things up, and we're gonna actually start with some nebulas today. So Zena had suggested that we start with the Saturn Nebula, which is a really nice object that we looked at while we were looking for targets. So, Zena, if you're okay with me just kind of slewing to the target, and then you can talk about what we're doing. Does that sound good to you?
absolutely. Yeah.
Okay.
So we're looking at. I figured since it's Vancouver and we can't really trust the weather and it might get cloudy any moment, so why not go with our favorite ones or the new ones that we were looking at last night and the Saturn Nebula that we saw last night. It was so amazing. They're so pretty. I haven't seen it before, and since we're also looking at Saturn later on in the night, so I figured, you know what? Let's start with the Saturn Nebula. Let's see how it looks. To give you some fun facts about Saturn Nebula, so it's a planetary nebula in Constellation Aquarius, and so planetary nebula, for those who don't know what that terminology means, it's actually it's a star dying nebula, and the reason behind the term planetary because when astronomers looked at it for the first time, they said it looked like a planet, so that's why they decided to call it planetary, even though nebulas have nothing to do with planets, which is funny. And the Saturn Nebula is also discovered by William Herschel in 1782. And the Saturn Nebula is about 5,000 light years away. One of the things that I was so excited to see this nebula is that because of the name. So it's like, oh, Saturn Nebula. Does that mean it doesn't look like a Saturn? Are we going to see the rings? And I'm actually curious about your feedback when you get to look at it.
Yeah.
Actually,
So
so how did you find it? Like, you're the one who actually suggested that nebula. Like, how did you came across like doing this, like finding this nebula? Like, was it on your mind for a while?
yeah,
Or
so while we go over that, sorry, let me just clear up the picture a bit, I'll touch I'll just give you guys a brief over, like a summary of how I kind of came across this one. Um, Sorry, Zena, let me just quickly clear this up so we can get a better view. But I think we should have it in the center of our stream now. Um,
nice.
so let me just and obviously one of the things that we just want to remind everyone in the audience is obviously with the observatory being at Burnaby Mountain. um, it's nice to have the observatory on a mountain, which is, of course, always a plus point in terms of where it's located. But then it also doesn't help in terms of the light pollution that's around the mountain. And on top of the mountain, with so many constructions in and around the area of the observatory, and also, closer to
And this
the.
light too around the dome doesn't
Yeah,
either.
yeah, absolutely. So that's why it gets a bit harder. It gets a bit hard um, to look at certain targets. But yeah, so while I was preparing for this week, I was just kind of going through one of the star charts that I use on my own personal time when I have to look at deep sky objects or anything like that. Um, well, obviously one thing is using the observatory telescope, but I have my own telescope which I like to use sometimes as well. Um, and with the current situation that we're in terms of the pandemic, it's obviously a bit hard to do other things. So it's always nice to just head out with the telescope. So one of the objects that I came across was this nebula in the star charts, but um, the usually the spots that I go for viewing. It they are a bit they are getting to a point where there's also the light pollution is getting there, so I wasn't sure if I would have been able to see it or not. And that's why I had figured, you know what, I'll keep this in mind for when we do the SFU Starry Nights, because of course with the telescope that we have the ability to take these small pictures of the target that we're looking at and stack the images, which is basically what I'm doing right now in this program. While um, while the images are being stacked, the picture gets better and better, and then we have set up the program such that it'll reduce sort of the background light as much as it can. And what we're doing right now is we're just kind of sharp tuning the image and getting a clearer view. So I'm gonna keep doing that, and then Zena, you can talk a bit more about the object. So yeah.
Actually, I was wondering, can you zoom?
Oh
Can you
yes.
zoom in? Yeah, because it's very like on the YouTube channel, I can't. It's like very small, so I'm wondering if you can zoom in on it.
Oh okay. Yes, absolutely.
It's because it's hard to see that, because I know last night when we saw it together, we can kind of see the rings. That's why it has that Saturn sort of shape. But I think
Yes.
from the YouTube channel, it's hard to see.
Oh right. Okay. Let me just see how I can do that. Just bear with me a second.
So I'm not sure if the audience can tell from the photo. So it's it's so with planetary nebula, it's so the star. It's like I mentioned, it's a star death nebula. It means the star already died and transformed into its next fate, which is a dwarf. And so stars will have low mass or considered of a low mass, like our sun. They when they die, they turn into a dwarf. And this one in particular, it's a hot bluish dwarf, like maybe you can even tell from the photo. And usually they are very hot, like they would have a temperatures of 55,000 Kelvin, which is really hot. And yeah, eventually, like those low mass star, like before they turn into a dwarf, they would actually first they go through what's called a red giant phase, and then that's the phase where they just shed all their layers and all their energy, and yeah, and eventually they just become the dwarf. And dwarf, they're just made of um, they're like a diamond because they're all just made of carbon, lots of chains of carbon. So that's what diamond is made of. So you can think of diamonds in space.
That's very cool. Um, so I did try to increase the area a bit. Hopefully that helped. I'm not sure. I'm really sorry if that didn't. I am using a different monitor this time around, so I really hope that's not the reason why this is happening. So, did that make a difference, Zena? Is that a bit zoomed in as opposed to before?
Slightly.
Okay.
You can actually zoom the photo itself.
Oh yeah, we can do that too. Yeah, I can definitely highlight the area of the photo. Let's see.
Yeah, I don't know. Somebody meant Alexander was saying gotta go to 1080p. I think he meant when you're doing the streaming. But I think you already picked
Oh,
up, right? I think you already had 1080.
you know what? I would have to check again. I think this one was already on there, but I think I already selected that option. But it could be that it's not.
I think it is because if I have it on mine, then you probably will have it as well.
Right.
But I could be wrong. But I could be wrong.
Again, the streaming aspect. Sometimes it is a bit challenging, but I think as long as we're able to get the object in the center, I think we should be okay. So let's see. Did that make it any clearer in terms of looking at the object?
Oh, much better. Look at that. At least you see way more details of the object.
Yeah, absolutely. So as you'll notice, like obviously uh, the software itself is taking more and more pictures, and as the pictures are getting stacked together, the object is getting clearer and clearer. Sorry, you're getting more detail from the object. Beg your pardon, not clearer, but clearer per se. But you're getting more detailed in the object as well. So now you're actually able to pick the center of the nebula, which is what Zena just briefly which is what Zena just briefly talked about, where the core is, the dwarf star is now. So, um, and this is what happened. This is the one good thing about obviously using a telescope which has that capability because especially for public settings or sorry for public viewings, it's great to have the capability of showing the clarity in the images and even the detailed in the images because from using your own telescope, or let's say if you're using a telescope which doesn't have this capability, the nebula is not going to look like that. It'll probably you'll probably have to go to even a darker part of the city or of the province to get some details from that object and how you can look into those details. So that's why it's nice. It's nice for us at least to have the ability to use the telescope like this and show some of these objects which may be hard for some amateur astronomers to look at. So um, and even the public. So I think that's really neat.
Oh, absolutely. I, this is so beautiful. This nebula that you picked. Good choice.
Yeah, I'm glad that the sort of the we are kind of looking away from the cloud, so I'm glad that that's not impacting it as much right now. Um, just going through.
Which direction is this? Somebody was asking. Which part of the sky are you looking at?
Oh, okay. So the Saturn Nebula, it's actually in the constellation Aquarius. Um, and Aquarius right now. The way we kind of also figure things out is we use one of the programs that obviously we have. It's called SkyX, and can actually help us identify which area we're looking at right now. So the constellation Aquarius is right over here, um, in the center. I do apologize. I think the stream is a bit behind, but you'll get there in a second. And the nebula itself, it's very close to the constellation Aquarius. So I think this would be right now in, I want to say southwest. Is that right, Zena? Or am I thinking of the opposite side?
It's hard for me to see.
Right.
I can tell from Stellarium.
Yeah, absolutely. The other thing is, we are able to obviously, quickly look up things if we need just clarity. But I want to say southwest, because I think that's where Aquarius is right now, or it could be. I'm just thinking about the opposite direction. Um, but but yeah, maybe someone in the chat can better assist with that question in terms of which part of the sky we're looking at. Oh, you know what? I was very close. I think.
Yeah, you were. So southwest, you're right.
It, oh, I was sorry. I was just gonna say no, Zina. I think it's like southeast or southeast. I think that's where it is. But it's okay.
I was looking at Stellarium.
Oh, okay.
And I just googled. Well, not Google. Sorry. I just looked for a setting on Stellarium. I looked
Okay.
for Aquarius. It's between south and west.
Oh, okay. I just got Kyle confirmation that it is southwest, so you know what, we'll just go with that. And if it is wrong, I'm sorry guys, but I'm sorry everyone, um, but yeah, it's definitely easier. It's definitely easier when you're out in the field because then you know where things are. Because right now I'm obviously at home and I'm operating this from my home. So
you know what's interesting about this? You know, like this nebula is in Aquarius and it's called Saturn, and Saturn and Jupiter are close to Aquarius too.
Oh, is it? So it all worked out.
Yeah, so like if we want to, we can even go to if we want to jump to a planet afterwards, we can. It's gonna be
Yeah, maybe we can do this time around. I know for the last time we sometimes have this structure that we tend to follow, but you know what? It's okay. We can definitely look at a planet and then we can kind of go around for the other targets. And if you're hearing a train right now, this is the other perks of working from home. This is the 10:30 commercial cargo train that is passing by my house right now, or close to my house, obviously. Um, but yeah, so you may hear that as well because I live very close to the train tracks. Okay, so what do you think, Zeno? Should we move on to a planet, or did you want to try a different nebula, or perhaps should we try a cluster? Maybe we can try that.
Well, I was thinking, so why don't we try the ones that are close to the actual constellation, since we're already in that area.
Okay.
So do you want to just jump to the Saturn and Jupiter?
Yeah. So how about this? We'll go to Jupiter now, and then for Jupiter itself, it'll be a bit different. We don't really need the live stacking, and yeah, maybe Zena, did you want to sort of describe why we actually don't need live stacking for planets and even stars?
Because just because they're already very bright. and they're close. Like, well, planets they're close to us, but with stars itself, they're already super bright, so we don't really. That's why. Unless is
Yeah.
there more to that?
Yeah, essentially that. Yeah, absolutely. No, no, you're right. You're right in the you're right there in terms of the description. Yeah. So, with planets and the stars, obviously with the planets they're quite bright. Um, Jupiter being the largest in our solar system, you don't really need stacking for that. And uh, what we do is we'll just do a quick exposure. So what we're doing is we're just opening the camera that we have on the telescope for a very small amount of time. So in this case, it's at 20 seconds right now, and that's why you'll see very overexposed. But we'll just go ahead and change it to, let's say, 50 milliseconds. And okay, so we're getting a bit clearer, a bit more clarity. You can see a bit of the moons of Jupiter as well. So the four Galilean moons. Uh, if I'm looking at it if I'm looking at it, I can only see three right now. So, um, uh, obviously with the four moons, it's Io, Europa, Ganymede, and Callisto. Um, so it could be that either one is a bit far out or it's hiding behind the planet. But let's drop the exposure to even less than 50 millisecond. We'll kind of get it even lower and lower, just to get a bit more clarity. Um,
Yeah. Like the point of doing all of this, like with like when we do a nebula, so nebula they're far away, they don't have as much light, so we want to collect as much light as possible from the object, and with objects like the planets and stars, we don't really need to have that many times of exposure.
yeah, absolutely. Obviously, with one thing is about nebulas, and the other is also galaxies. With galaxies, we sometimes have to even get a larger exposure because some of the galaxies they're so far away, and they're quite large as well. That's the other thing. So sometimes the light is scattered all around the galaxy, and that's where we have to do a larger exposure. So that's why sometimes that's the case with galaxies where we have to do longer exposures. But I think for Jupiter itself, I think we are there. I'm gonna try to zoom in a bit, and see if we can make it. Better for the live stream audience.
Nice.
So
Oh, nice. You can see the lines on Jupiter.
yeah, so do you want to talk a bit about that, Zina, on why exactly we have those lines on the planet?
Well, isn't Jupiter your favorite planet?
You know what?
I
Mine.
thought you would want to have that planet. I figured like this planet is yours.
No, mine's actually Saturn.
No,
Mine's
really? No
no.
way. You changed.
No, no,
No,
no,
you
no. You're
changed.
right. Mine's always been a mix up between Jupiter and Saturn.
'Cause I like
Uh,
Saturn. I've never like
Yeah,
Jupiter.
it's mine's always been a mix up, not a mix up. Mine's always been a toss up between Jupiter and Saturn. Well, Jupiter was the first planet or the first object I ever looked through my own telescope, and that's why it has a very special place in my heart in terms of what I looked at. Um, so that's why yes, you are correct. So the lines itself. So going back to my original thing where we're going to talk about the lines in Jupiter. So obviously Jupiter, largest planet in the solar system. Majority of the planet is hydrogen and helium, and what's happening is that these swirling lines or these swirling colors that we see on the planet, these are actually sort of the gases in the planet that are churning from below. Now, what ends up happening is that all of these gases they're going quite they're going quite fast as well. I think some of the speeds can reach up to 500 to 550 kilometers per hour, and obviously it produces large storms on the planet, and one of the biggest one in our solar system, the Great Red Spot, is on Jupiter, which of course is the storm as well. So that's essentially why we get these lines, and when we look at Saturn as well a little bit later tonight, we'll kind of see the same thing as well. We'll see those gases which are kind of swirling at so high speed, and that's essentially what's causing these different lines on the planet. um, and the first time I remember the first time I actually looked through it, obviously, like, I've seen the planet, seen pictures of it, and all of that, but uh, it, it's it's hard to describe now, but at that time, maybe I looked through it at that time, there was not a lot of light pollution where I was, and it just you just have to take a second and admire, like, how much you can see from here. The planet itself, far away, and I think the distance to Jupiter, it's approximately, I'm thinking about like 600 million kilometers, something like that, in sort of the estimate. So, quite far away as well. But when you use your telescope and you look through it, that just it doesn't seem that far anymore. It seems like, oh, it's right there, and you're just kind of looking through it in the telescope. So yeah, that's just a personal story that I ended up sharing. But that's essentially what I would say part of astronomy is, right? Like, we all come across these personal experiences that we have. Um, so it's nice to be able to share that with others as well. But yeah, how's the view looking for the planet in the stream? Is it
It looks good. You can
okay?
make it slightly brighter.
Oh, let me see if I can try to
But otherwise,
increase.
you can definitely see the lines. I'm wondering if you do you see the red. Do you see the red dot on your end?
I oh, I did something. Sorry, just give me 1 second. I don't see any.
Because I remember last time I looked at it, but that was sometime in August. I was able to actually see the dot, the red
Okay,
dot. So
yeah.
I'm
So
wondering, do you see it on your end?
no. So with the red spot, I think it is that it comes on. I think I'm fairly certain that there is a way that it, like, you can look online, like, where it would be. But again, I didn't prepare for that, so I wouldn't know what it is. But as far as I
But
can
I was
see
just
right
curious.
now, oh yeah, sorry. What I was just saying is, Zena, what I don't see it right now, but I'm sure maybe the next time we have a Starry Nights, we can kind of keep this as a yeah, we can do this. I think we can just make a note, right, and we can kind of see if maybe next time we can see it. And again, I don't know if the 2 millisecond exposure is enough to see the spot either. Um,
Yeah, that's fair.
but of course, we can definitely try this next time. This is something that we can take back and see what happens. Yeah.
Yeah, I was just curious if you can see it because I
Hmm.
don't see it on the stream. So I'm just wondering if it's just
Yeah.
maybe that's the reason. It is
Yeah.
small. I mean, it's not small when you
Yeah,
go
it's
think.
not small per se, but because we're what, 600 million kilometers away, it is quite small from
Although
our.
I mean, that red spot, it will suck the Earth. Like
Oh,
think
it
of
will.
the
Yeah,
Earth,
definitely.
it's that
Yeah,
big.
I think if I remember correctly, I think it can fit up to like 11, no, maybe it can fit up to 5 or 6 Earths. I'm not, maybe, I think. Maybe someone in the chat can better assist with that part, but I think it's somewhere about 5 to 6 that it fits in there. So yeah, I mean, Jupiter can take up to like 11. Jupiter is 11 times the mass of Earth. Um, so it can take a lot of it can basically suck everything in there too. And I don't know and I'm sorry, Zena, I don't know if this was mentioned or not, but Jupiter is also sort of the vacuum cleaner of our solar system. Um,
That's I've never heard it being described that way.
well, I mean,
That's the first
it
vacuum
will, right?
cleaner.
Like, yeah, but I mean, it'll suck in, all of those asteroids that are potentially coming towards us. Obviously, the famous one in the 90s was the comet Shoemaker-Levy. That was the big one
Yeah,
that collided on the planet. And I think just like maybe 2 or 3 weeks ago, there was another one. I think there was an amateur astronomer who captured like a sudden flash on the surface, like on the planet itself. Um, so that was very cool. Like they had the video and everything, and I think it was. And you know about the astronomy picture of the day, right? But we can briefly talk about that too. But it was on there. It was on astronomy picture of the day. Like someone captured it.
it
So
was
that
a
was very
what
cool.
was it? Was it a comet or an asteroid?
Well, yeah, I mean, so it was basically a comet going around, and then I guess it got sucked into Jupiter's gravitational pull, and then it ended up colliding with. Yeah, I mean, it ended up obviously getting colliding with the planet itself. So yeah, that was very cool. Yeah,
That's
so
incredible.
yeah, so
Somebody was
astronomy.
there just take a photo of it or to
Yeah,
capture the moment.
yeah, I mean, it's just it's crazy, right? Like they were at the right time at the right place, and they had the right equipment, looking at the planet itself too. So that was very nice. But no,
How come we didn't get a chance to do it with our observatory? Was it raining? It was probably
it
raining.
was probably raining, and then I was gonna say we would probably have to keep the telescope pinned at Jupiter for like 6 7 hours or something, and who knows in that 6 hours how many times it may rain. so so
Yeah, that's true. I mean, we've
so
done it. I'm sure some of us have done it where they stayed up all night just taking images and while watching Star
yeah,
Trek or
yeah.
eating pizza.
Yeah,
That's what we
absolutely.
do. I'm
Um,
sure Matt can also agree with me. He does that.
yeah.
Sorry, I didn't mean to out Matt if
No,
he's in the
no.
audience.
Yeah, I think it was very different, obviously, when we had the in-person events. But anyways, that's a different story. So yeah, just briefly, astronomy picture of the day, just a database where you can go online and look at nice pictures of the universe. And it doesn't always have to be astrophotography. There can be ranges. As I mentioned, one of them was about the comet colliding into the planet, as well, or sorry, the asteroid colliding into the planet itself. So yeah, something to look for. But yeah, having said that, should we, Zena, what do you think? Should we move on to Saturn now? Should we try that?
Yeah, let's do that.
Okay, sounds good. I'm just
Saturn,
going to.
our favorite planet, the most beautiful planet.
Yes, uh, would you say it's the crown jewel of the solar system, Zena? Is that where you're going at?
Sure. I mean, if you think about it, I don't know if you know this. I learned that it rains diamonds in Saturn. I don't know why I keep
What?
mentioning the diamonds. I think there's a diamond theme in space.
Wow. I
But no,
mean,
I was amazed. Like, what? It rains diamonds? Where I want to move there. Yeah, but it says like it rains diamond. I was trying to figure out how that's possible. So with Saturn, like there's obviously there's a lot of gases and there's lighting, and the power of the lighting, what it does, it transforms the methane gas into clouds of soot. So soot is just like a type, like it's a form of diamond. So that doesn't, but they say that the diamond doesn't stay there forever. Like it doesn't stay solid as a diamond. It actually later on becomes liquefied. But still, it's quite amazing. It's
wow,
raining
that's
diamonds.
that's new. I didn't know about this. I mean, obviously, um, one of the most common elements in the universe is hydrogen, but I didn't realize that this diamond thing also happened on Saturn. I think it's Neptune, right? Zeno? Like Neptune is one of the planets where it rains diamonds as well, like proper diamonds. I think.
All right.
I'm
Depends.
fairly
But if
certain.
it has methane, then it would make sense. If it has methane and lighting, then it would. I would believe so. I don't know.
I'm
Actually, I don't know about Neptune if it actually rains.
I'm fairly certain it is. If I
But I
remember.
won't be surprised because there's always that diamond theme in space. I'm not surprised.
Okay.
We might be even living in a diamond's, space. Like we're living inside a diamond and we just don't know it.
Yeah, absolutely. Okay, just.
The universe is a big giant diamond. That's the new conspiracy theory. No, I'm just kidding. No.
Let's.
Nobody will quote me on that.
Yeah. While I just clear up this picture, just give me one quick second. Yeah, so lot of the some of the other challenges is obviously clearing up the picture that we can see. Um, with Jupiter, we had to do a less exposure, obviously because not obviously, but with Jupiter we had to do a less exposure because the planet is quite large. Um, a lot of light is coming from there. But with Saturn, we have to do a bit longer than what we were doing for Jupiter at least. So um, while I'm clearing this up. Um, um, okay, let's see. I'm just gonna look at the. Oh, I think we're good in we're good in the chat. So thanks again for the moderators in the chat for assisting with that. But yeah, so this is Saturn. So we're looking at Saturn right now. Let me see if I can clear it a bit more. But Zena, I think this is your favorite planet, right? So maybe I'm going to pass over the torch to you now for this one.
Yeah, Saturn. It's like that planet where it has. I think because you can see the ring. It's like it's unique. I know Neptune has rings, and some other planets will have rings. We just can't see it, but Saturn is the one where the ring is very visible. And the nice thing about it, like Saturn is probably the only one that has this 3D look to it. And because when we look through a telescope, when we look at objects, we usually only see the 2D version of it. It's a 2D. But with Saturn, it gives you that 3D feels. So maybe that's why I like it. And one of the interesting facts about Saturn is that it's so it's not dense in the sense that it can actually float on water. So if you were to think about water that's like a bucket of, if you were to take Saturn and put it in a bucket of water, it will float.
Mm-hmm.
That it just means that water is denser than Saturn. So isn't that cool?
That's crazy. And I mean, again, it's so far away. Like it's further than Jupiter, obviously, right? So just thinking about the fact that there's there's a planet out there that can float on water. It's just, yeah, like obviously, not to scale and all of that, but it's just crazy. I think Jupiter is 600 million kilometers, and then I think Saturn is maybe double that, or maybe no, I think it's even more than that. I'll have to I'll have to look it up, but it's even further, and that's why it's just crazy on how far these things are and how far we can see. Sorry, Zena, what did you say?
No, I just learned, I just remember something else about Saturn. So Saturn, because it has, how we, like how the Earth rotation axis, it has it's on an angle. Like ours is 23 point, is it 23.5? I could be wrong, but I know it's 23 point something.
Right.
So Saturn has a similar angle, like similar axis angle as Earth. And when you have that, angle, you actually create, that's what gives you these seasons. And so Saturn has seasons just like Earth, except the seasons on Saturn, they spend much, much longer than on Earth. I think if I remember correctly, summer lasts for, I think, about 8 years, 8 to 7 years on Saturn.
Oh, wow.
So here is a question for you, Rohit. So if you were on Saturn, which season would you want to go spend on? Like, let's just say we are capable of going to Saturn, but then
And
you want to.
surviving, capable of going to Saturn and surviving.
Yeah, AKA surviving, or let's just say we evolve into creatures that can survive on Saturn.
You know what? You know what I would. Instead of doing that, instead of looking at the seasons or whatnot, I would rather go or try to observe the polar regions of the planet, because just like
Oh,
on Earth, we're in our polar regions, we get the aurora borealis in the northern hemisphere and the
yeah.
aurora australis in the southern hemisphere. Saturn also get auroras as well. So I would love to see that instead of spending my summer on there, because I probably won't survive on the planet. But I think that's what I would like to do instead. And Jupiter too. Jupiter has auroras as well, right? So that would be something nice to look at.
Wow. So have you seen aurora here, like in Vancouver
So
or
you know
Canada?
what? Yeah, so it's interesting that we're talking about this, because I one of the times that um, pre-pandemic times, we would go to uh, one of the, so obviously in conjunction with the Royal Astronomical Society of Canada and the Fraser Valley Astronomy Group, we would go out to Merritt, and we would basically do stargazing from Merritt. There's a campsite about 40 to 45 minutes away from there that you can set up, and you can kind of stargaze from there. And I've seen the auroras from there. They're obviously very
Wow.
faint. Yeah, very faint, like hard to pick out. But yes, like definitely seen in there. The other thing before I forget, I just wanted to mention was one of the moons of Saturn, Enceladus. It's actually an active moon that hides a global ocean of liquid salty water beneath its crust. So there is a moon in our solar system which does have, water, and obviously, water is essential for life too. So who knows? Who knows what's on there? We'll just have to, maybe we would have to go and figure it out. So maybe that's what we'll do, Zena. Instead of going to Saturn, we'll go to the moon instead. We'll go to the moon. We'll plan some sort of expedition or
Live on the
something.
moon.
Yeah, we'll do that. But yeah, no. So
Well, if I had to pick a season, I'll go for spring. So I can have all these flowers and the cherry blossom. I mean, it would suck for people who are allergic to pollen. I mean,
but is
I
it
hope I
is
don't end up being allergic.
but are isn't that the but then we're under the impression that there's actually plants and flowers and trees on the planet, which is not the case.
Yeah, I know, it's true. That probably won't be.
Okay.
If I had to choose a season, if it exists,
Yes.
I don't know what spring looks like on Saturn or even summer. It's
It,
probably
it
not the
would
same seasons
it'll
that
probably
we
be the
have
same
on
seasons.
Earth.
Yeah, yeah. I think it's like a year on Saturn is more than 29 Earth years or
Oh
something
my
like that.
god.
Yeah, so that's gonna be quite a um yeah, that's gonna be quite a feat to accomplish. I think, just being there for so long. It's
Oh,
like,
for sure.
in 2 Saturn years, you are suddenly almost, pushing 50 or something. I don't know if you were born on the way there. I don't know how it would be, but anyways, so yeah, so that was Saturn, and I think
You
we
know what
can.
else is interesting about Saturn that I
Oh,
learned?
yeah, go ahead.
Saturn, you know the rings?
Hmm.
Actually, I learned that actually it will disappear one day.
Yeah, so I've been I kind of looked at that as well, but or sorry, I've heard about that as well, because obviously, the planet is kind of pulling everything towards it, right? And right now
Yeah.
they're all in this perfect symphony, and that's why we're getting these beautiful rings. But yeah, I mean, I wouldn't be surprised if that happens. What, in, I don't know, 30,000 years? Zena, is that the estimate that they said? I don't even know.
I think it's like it won't be within our lifetime.
Oh,
It's like
okay.
within 100 million years.
Oh wow. Okay. Oh, I'm sorry. I was very optimistic then. so so
You
yeah.
want to you want to witness that
No,
event,
no, not at all.
Saturn
I
losing
would I
its
would I would want to see Saturn as it is right now. How about that? Let's just keep it at that.
exactly.
Yeah.
It's funny, like if Saturn loses its, I just can't picture Saturn without its rings. It's like
Yeah.
it's not
Yeah.
Saturn. It can be Saturn without its. rings.
No, absolutely.
Have to be named something else. It's no more Saturn.
Okay, so yeah, so that was Saturn. I think. Yeah, how about we go to a star cluster? Zena, what do you think? A globular cluster, maybe?
Sure. Don't. Which one did we have on our Did we look at star clusters last night?
Yeah. Let's okay. So I have two in my mind that I think that we should look at, which I think would be really nice to see. So we can start with one of the. Yeah, let's start with Messier 56, which is in the constellation Lyra, because it's high up. I think it'll look nice. Sorry, not high up, but it's up. So we won't have a problem in terms of the light pollution, at least. But yeah, let's try to look at that one. And Messier 56 is very cool too. I mean, all globular clusters in general are very cool in terms of their properties and the one of the things that really kind of blows my mind about the the globular cluster is their age, but I'll talk about that in a second. While we kind of wait wait for us to get there, we'll give it a couple of seconds. And oh,
yeah, they are very globular cluster are they're interesting objects to study. And I think many astronomers would like to study those globular clusters, or even the open clusters, how they end up being a globular cluster. But you're right, it's mainly the age, because studying globular cluster, they reflect the age of the universe because they are really, really old, or they're very close to the age of the universe. How old is our universe? Is it like 13.8 billion? I think.
Yeah, so it's like 13.4 plus or minus. I think it's like 13.4 billion plus or minus like 2 or 3 billion or something, just because of the estimate that they have to do. Um, yeah, Zeno, while we were
All the
discussing,
globular clusters are in the billions. Like they're 13 billion something as well.
yeah, yeah. Okay, so while we were talking, for some reason the dome has decided not to move. Okay, just give me a second, Zena, while we try to figure out why the dome has decided not to move.
Oh, is it too low? Maybe it's below the horizon, or is it
No,
in the
no,
seabed?
no, we're good. I'm not sure. I think for some reason we lost connection to the dome, but we're good. We're back on track.
Okay, sounds good. Sounds good. Yeah. It's interesting with the globular cluster. I think, I keep forgetting the name of that astronomer, but what he did is that he was able to use the location of the globular clusters in the night sky from Earth perspective, like where they're located, to figure out that we're actually not our solar system is not in the center of the Milky Way. That's actually on the edge, or one of the arms of the Milky Way.
Oh yeah, you know what? Yeah, and I'm blanking on that now because yeah. Sorry, I thought, Zena, for a second there you were gonna talk about the like how the globular clusters, like some of them, they have variable stars, and I thought you were gonna sorry, like discuss the like this the obviously the Cepheid project that we did for the Andromeda Galaxy.
Oh yeah, of course. Yeah, you
Yeah.
can talk about that if you want.
Yeah, no, that's okay. But yeah, I think sorry, let me just clean up this image while we're talking about Messier 56. And again, I think this obviously, sorry for the stream being a bit behind, but I'm just cleaning up the image as we are discussing. So really good, a really interesting thing about globular cluster. They're actually the oldest. They're actually the oldest objects in our universe. the age of the universe, as Zena just mentioned, it's roughly 13.4 billion years, billion light year, 13.4 billion years. Um, and and with some of these globular clusters, they're around that time as well. So we're looking at Messier 56 right now, and the age of this object is 13.70 billion years. So just right around that time, and obviously there's that error plus or minus 1 or 2 billion years. Um, but but yeah, so all of the stars in a globular cluster, they're very tightly packed because of their mutual gravitational forces, and they're all kind of in a um, in a center of area, and then that's why we call them globular clusters. And the other thing is, like, for this object specifically, this one, from one end of the cluster to the other, it's approximately 84 light years. So this means that, hypothetically, if one would have to travel from one end of this cluster to the other, it would take them approximately 84 years to accomplish that. Um, accomplish uh, that travel. So, um, how's it looking in the stream? Are we able to?
It looks amazing.
Okay, okay.
You're
Sorry.
doing a
Yeah,
great job.
I
You're doing a
was.
great job, Rohan.
Yeah, sorry. I was clearing, like, I was cleaning it up, and then I just forgot to check the stream real quick just to kind of see how we're doing with it.
You can
But
even
yeah.
make it bigger if you want, or zoom in.
Oh, I think I just did. I think it's just catching up on the stream, or
Awesome. Yeah, it's very beautiful. And like when we since we're talking about the age and how old they are, so if you notice that all, and I see it from the image too, even from the stream, is that most of the stars in that cluster, they all have that orange red color. So that kind of also reflects the age, like, so the age of the cluster you can tell from the age of the stars in it. So the red stars tend to be more closer to dying or older, and the young stars tend to be more bluish, or blue stars are young, red stars are older and cold.
yeah, no, absolutely. And that's the interesting thing about these objects as well, right? Because, um, I mean, just looking at this, it just obviously just looks like stars in the middle of the night sky. And I remember the first couple of times when I looked through them with a telescope, I just could never imagine them being so old, right? And a lot of these globular clusters, the other thing with them is, which I was talking about a bit earlier, is, a lot of them, they have variable stars as well. So, variable stars, when viewed from Earth, their apparent magnitude fluctuates. So what ends up happening is that it can either be because they're going through these luminosity changes, because sometimes the stars will swell, like they'll swell or shrink, based on, either they're burning off their fuel, and because of that they're going through these changes in brightness. Or the other reason could also be where, some of these stars, they may even have an orbiting companion. So it may be that some of the stars, there is in a variable star, some of them, they're in a binary formation where, there is a star next to them, and they're kind of going around in this orbital dance, and that's kind of affecting their the magnitude as well. So it's just, it's very interesting, and sometimes it makes you feel very small, because obviously, this object, so this object itself, I think it's about 33,000 light years away, so quite far away, very old. But on top of the fact that it's a globular cluster, it has variable stars. So then all of a sudden you're thinking about that, and that's not even the end of it. So this M56, out of all of those things, it also has a Cepheid variable. So it doesn't even stop there. So it kind of just, goes from, oh, this object has variable stars, this one has Cepheids, And then, for example, Andromeda Galaxy, it has Cepheid variables as well. So it just kind of continues on and on, which of course is kind of the neat thing about the universe, where there's always these little hidden things in these objects that you can talk about, or you can even look at. So yeah. Sorry, I know I went on a bit of a tangent. Sorry, Zena.
No. That's good. That's good. That's all really interesting information. It's good to know about the variable stars. I think many people, people in the audience, they may not know what variable star is. So it's great that you explained it.
Yeah.
Even for me, I didn't know about variable stars until I joined the Trottier Observatory community.
Yeah.
And I learned even that the project that we did with the
Cepheid, yeah.
The Cepheid project and the paper that came out.
Yeah,
that's when I learned about all the concept of variable stars.
No, absolutely. So yeah, so this is M56, and as I mentioned, this is a globular cluster. Now, there's other globular clusters that we can also see as well. So, for example, one of them is M13, which is the Great Hercules Cluster. We've done images of M13 as well using our own telescope. And that is something that's on our SFU Observatory webpage as well. So I urge everyone to take a look at that as well. But talking about the clusters, I think now is the right time to switch to an open cluster, because this is where it gets even more interesting in sort of the stark differences between the closed and the globular and the open cluster. So, Zena, are you okay if we move to an open cluster and then
yeah, absolutely. Okay. That's funny. Yeah. Open and closed.
Yeah. Sorry.
I could totally. I mean, I don't see why not. But makes you think, like, why did they even call it a closed cluster? Why are they calling it globular?
Yeah. Yeah, and you know what? And if we have time, what we'll do is we'll quickly look at another globular cluster as well. Yeah. But let's do an open cluster now, because I think.
Which one do you want to do? Do you want to do M52, or there's that one NGC 869?
Yeah, we may. Cluster? Yeah, absolutely. I think. Okay, let's try M52. We'll kind of stick with the messier objects and see. Sure. If we can see how it is, and if not, then we'll kind of I don't know why I did the caps lock there, but yeah, we'll try to do that, and then okay, let's see if we can slew. And I think the observatory will just do a little bit of adjustment as well while it's kind of going.
So I guess, when did the naming come? So I guess open, I'm assuming I'm assuming most the astronomers, they found globular clusters first. Do you know if
Yeah, that's actually a really good question. So with the globular clusters, these were obviously, with Charles Messier and him looking for comets and finding these Messier objects. That's one thing, but yeah. So like with the globular clusters, they were easy to spot because, again, very easy to spot in terms of all of the stars are in one area. There's clear definition in terms of what they can see through their telescope at that time. And it's obviously it's a bit challenging with open clusters, because, I mean, sometimes when you look through binoculars into the night sky, it's almost like anything can be an open cluster, I would say. Right? So sometimes that is the case as well. So yeah, I totally. I think if it was at that time, it would be sort of a which one is the globular cluster and which one is the open cluster. I definitely agree with you. Okay, so let me just try to clear this up while we're just looking at the object. Yeah, so one thing about the open clusters as well is that these are very young. as compared to the globular cluster.
Define very young from a. I think the audience may not know what very young means from a space perspective.
Yeah, that's a very good point, Zena. So this object, the age is approximately, I think it's about 160 million years, as opposed
oh my gosh,
as
very
opposed
very young.
as opposed to the previous cluster, which was 13.6 billion years or something. So yeah, this one it's relatively young. I mean, compared to the age of the universe, Xena, it's very young. I mean,
What about our lives?
yeah, I mean, I'm not talking about that. We're not discussing our lifetimes. We're discussing the age of the universe.
Like our lifetime is nothing. We're like what? Maybe short. Really,
So
short.
So it's really interesting you're talking about this because it's a good. I can now sort of pitch the cosmic calendar that we have at the SFU Trottier Observatory. Obviously, with our in-person sessions, it would be so great that if we could talk about the calendar, and maybe we can for another time. But on so if we put the entire, from the start of the Big Bang to up until now in a calendar, us as humans, we occupy maybe, like 10 seconds, or sorry, not even 10 seconds, like 5 seconds on the entire cosmic calendar. And a really great representation of this was done by Carl Sagan, and it was also done by, I'm blanking on the name now.
The one I know who you talk about.
Neil deGrasse Tyson. Sorry.
Neil deGrasse Tyson.
Yes.
Yeah.
So a really good representation of that was done by Carl. Obviously the late Dr. Carl Sagan, and then also Dr. Tyson, and they did a really good representation of on how minuscule we are in terms of the universe. Um, so yeah, I mean, this is an open cluster, right? I mean, if one would look through the binoculars, this would just look like a group of stars in one area, and generally that's what an open cluster is. We will end up finding a lot of these, and there's a lot of open clusters in the night sky, similar to globular clusters as well. And you'll kind of notice as well, um, the differences between the globular and the open cluster here, where the stars are quite far apart. You may see some stars which are, um, you may see some stars, which are close to each other, like for example towards the corner of the page, sorry, towards the corner of the screen. But the others are quite far apart, and that's why, uh, and that's what ends up happening. And one of the theories is also about how, some of these may in some past time could have been globular clusters, but they've just kind of drifted away. The stars kind of move around, and how the universe is also expanding, that it ends up being that some of the stars, they drift away from one another. So for this one, I think as I mentioned earlier, the age is about 160 million years. So again, very young compared to the age of the universe, compared to the previous cluster that we were looking at. But yeah, so this one I think it's in the constellation Capella, and this is something that you can look through your binoculars as well. You don't need a telescope to look through this one, um, just because the stars are quite spread apart, and it can be something picked out easily with binoculars.
You know what? Like actually, globular cluster and elk clusters, they're actually really nice targets with binoculars. I recommend M13 if anybody likes to, star hub or stargaze with binoculars. Definitely, globular clusters like M13 would be a great target for winter.
Yeah, I agree. Oh, sorry, Zena. M13. It's good in the summer as well. Primarily in the summer.
Oh, okay, yeah. Which one is the one for the winter then? Was it the one for the winter?
I'm sure there are. I don't have any on top of. I don't have any listed right now, but I'm sure if anyone just kind of looks at globular, if anyone does a small Google search or a quick Google search for globular clusters in winter, they'll see quite a lot.
Yeah.
M13 looks very nice. In the summer, of course, given the light pollution and all of that, if that's the case. But it is something that you can look at right now. I mean, we can definitely see M13 right now as well. So you can try that. Did you want to try that, Zena? We can take a quick look.
It's up to you, but I think we've shown M13 many times.
Okay.
I feel like.
Yeah.
I was thinking maybe we can check a new one.
Oh,
So,
absolutely. So the other one I had in mind, a global cluster, was M92. That's in the constellation of Hercules as well.
oh, okay, there you go.
Yeah, so we'll be around that area. Should we try that one?
Yeah, let's do that.
Okay, okay, and then maybe we can then move on to some nebulas because I know I think we may be lucky with the weather today, so we should capitalize on the clear weather, and
Yep.
and move to some nebulas as well.
There you go.
And
Yeah,
perhaps
but that open cluster is really nice, by the way. It looks really nice on the YouTube channel.
oh, okay, that's good. And then I was gonna say perhaps we can try to see if maybe we can do Neptune towards the end of the night, but let's see. Let's see how it progresses.
That would be nice. I want to see if there are diamonds there too. No, I'm kidding.
So you know what? While you were talking about this, I forgot to tell you. Neptune, it does rain diamonds on Neptunes.
Okay.
Yeah, and it's a similar explanation, but obviously with the immense pressure and the high winds and all of that. So yeah, absolutely. Okay, so we are at M92 right now, and just have to do a bit of resetting, and then yeah. So this so again, this one with a globular cluster. You know what? This time around, I'm gonna put it up to the audience because now that we've kind of talked so much about these open globular clusters and open clusters, does someone wanna take a guess on the age? If someone wants to put it on the chat, and then maybe the moderators can kind of help us as well. But but yeah, what do you guys think? Without obviously looking, let's try to be honest here, everyone. Um, how about you guys try to determine what the age of this globular cluster is, and just take a guess, post it in the chat. A good way to interact with the moderators as well, and then we'll see what you guys come up with.
I mean, we can give them a hint.
No hints. I think no hints. We talked about globular cluster for quite a long time, so I think that we should be yeah. We're getting some so we're getting okay. We got one answer, so we'll kind of wait for more to trickle in.
The billions.
Yeah, so I mean this is a good way to make sure our audience is paying attention.
Right, because we're gonna have a pop quiz at the end.
Yeah, exactly. Sorry.
Did I say that? No, we're not gonna have a quiz. I'm just
No,
kidding.
no. I was gonna say that part of this SFU Starry Nights is obviously if someone is part of the telescope program, they can send an email to the SFU Science Outreach and letting them know that they attended the event, and then you also have to let them know what objects you saw. So yes, technically there is a pop quiz, but the pop quiz is by email. So yeah.
There you go. Look at that.
Yeah, sorry,
Yeah, that's pretty.
I got distracted talking about the telescope program. I'll get back to doing that. Okay, so we have two answers. So one was 10 billion, one was 13.1. Any other takers in terms of what the age of the cluster is, the age of the globular cluster is?
There's 13 billion plus or minus billion.
Okay, so we got that one there too. Okay. So I've cleaned it up a bit. Let me try to zoom in. Zena, should I zoom in on this one, or should we let it be? I'm not sure.
I think you should try zooming in. Doesn't
Okay, okay.
hurt.
I'll zoom in a bit.
Looking at it, but I don't see why you shouldn't zoom in.
Okay, I'll zoom in a bit, and then I'll try to clean it up as well. I lost the stream for a second, so that's why I couldn't see. Maybe I'll push a bit back. Okay, so yeah, Kyle is correct. Playing with these big numbers is quite mind-boggling. Yeah, absolutely. Okay, so yes, so it is in the billions. That's one thing. So this one, the age is approximately 12 plus or minus 1 billion years old. So anyone who said in the billions is right. This is this is where we are for this globular cluster, and you know, obviously the Hercules cluster is the big famous one in the constellation Hercules, but this is the less famous one, but it's still as pretty as the Hercules one in my opinion. Um, and this one is approximately, I think, 26,000 or about 27,000 light years away from us. So, also one of the other one of the other oldest clusters in our galaxy. The interesting thing is Hercules cluster is about 11.6 billion years old, and this is about 12. So this is actually even older than the Hercules cluster. But yeah, so you'll see how it can get quite yeah, it can get quite mind-boggling, as Kyle talked about earlier in the chat. But yeah, so this is another globular cluster in the constellation Hercules that you can see. It may be a bit hard. Sorry, Zena, I was just going to say it may be a bit hard to look through the binoculars on this one.
Oh, really?
Yeah, because I think the magnitude for this one is about 6, um, and it may be a bit hard. Hercules is quite easy. But if you are in the dark sky, if you are in a super dark sky, then yes, by all means, it'll be quite easy to look through. Um, okay, so yeah, this was M92, the globular clusters. So I think now perhaps we can move to another nebula. What do you think, Zena?
Yeah, let's do that. Let's do the. Well, you found another one that's really interesting. The Little Gem Nebula.
Yes, that was the other one that we saw yesterday. Let's try to look at this one and see what comes out of it. um, and remind me if and you know what, yesterday almost just feels like a memory now for some reason. I sometimes I find it hard to remember things, but was it clear, Zena, when we looked at it yesterday? I think it was, right?
I think so. Yeah. Like
Okay.
it was the same. Like it was the same size as the Saturn Nebula.
Okay.
So it's currently.
Okay.
But it was still amazing to look at.
Okay. My only I don't think it's I don't think it's low on the horizon right now. So we'll just kind of have to. Hopefully that's the case, and that's why I'm kind of slowing. Oh, you know what? I think we'll be fine. We'll be okay. I think. Where are we in terms of the? Yeah, I think we'll be fine. It is a bit low, but I think we should be okay. We'll try it. If not, we'll try another nebula. Um, okay, let me just get this.
Or we can also check a galaxy. Because we also looked at Andromeda last night. Andromeda
We did, yeah, we did. Okay, that's a good idea. I think let's try to see if we can get the nebula in, and if not, then we can try the galaxy, and even if we can do the galaxy as well. Um, okay, I do see something, but let's.
I see something too.
Okay, let's clean it up. I think I'm going the wrong way. Oops. Okay. Okay.
It's pretty. It's a pretty one too. Look, see, do you notice like how these like these like gem, diamond. Like there's all these, like stone theme things. Doesn't come
there is.
or gems.
I mean, like obviously with the naming, a lot of the naming conventions for these dark sky objects it's a bit out there as well. I mean, like for example, Ursa Major, like the Great Big Bear and all of that, like the constellation. Like sometimes it's a bit funny, of course, but yeah, no, the naming can definitely be out there sometimes. I know. I don't know if you remember. Like for example, this one time we tried to look at the Owl Nebula in the Big Dipper, like in Ursa Major, and
Mm-hmm.
I could never make out the owl. I could never make out why it was the owl or what it was, and I think I may have like looked at it like 4 or 5 different times, and yeah, I could never understand why it was the owl. But anyways,
Or what with me, like whenever I look at the nebula, or different nebulas, I see, especially the Starbirth Nebula, like the Lagoon Nebula, the Swan Nebula. I
yeah.
see different things every time I look at it. Like maybe one of the times I saw, like for this, I think for the Swan, I saw there was a submarine. Another time
Oh
I saw
really?
a fish, and somebody I don't remember that even different people from the island mentioned different things that they saw in the Swan. Maybe even the lagoon. So it's just those weird shapes that they make with the starburst nebulas. It just plays with our imagination, how creative we can be.
Yeah, absolutely. I'm just trying to clear up the picture a bit, but I'm just gonna. Um, how does it look in the streams? I think I just lost the stream again, but
Let's see.
I yeah, I
Oh,
mean it does look. I mean, of course, it does look like a nebula. It's there, but
looks good.
yeah, I think this is the one where we need more pictures for it to get a bit more, for us to get a pick more detail on this one. Obviously, with the Saturn Nebula, it was a bit easier because so the Saturn one is about 5,000 light years, and this one is about 6,000. So it's a bit further away. That's the other thing, and the other thing about this nebula, it also has like two distinct layers um, of gases, and I think it's a bit hard to see right now, the two distinct. But one of the, like, there's an outer layer which kind of covers, which nests the inner layer, and the inner layer is actually the one which is the brighter one.
Mm,
So yeah, it's a bit hard to see that right now, and I really hope that we continue to stack.
so
Uh,
beautiful. It makes me think of the Snowball Nebula.
yeah, it kind of reminds me of that one too, and this is what happened when I was looking at it yesterday, as well. Or sorry, when we were looking at it yesterday, right? Like just kind of how it was coming out to see. So um, okay, so is that zoomed in, Zena? Or do you think we should go a bit higher? I feel like that's if we go a bit higher, I'm not sure if
I
it'll look.
think
What do you
you,
think?
you might be able to go a bit more
A
zoomed
bit?
in.
Okay,
Yeah,
okay,
that
let's
should
try that.
give it a try. Yeah.
We'll take it slow. We'll just maybe go to 55% and see how that turns out.
And this is also a planet type. I'm sure that most of the audience know what type of nebula this is. This is like planetary nebula because it has that planet-like shape. While starbirth nebulas, they don't have a specific shape. They make up any kind of shape. Like they're like clouds. That makes me think of clouds.
Yeah.
Starbirth
So
nebula.
so a good example for that one is obviously the Orion's Nebula, right? Because
Yeah.
that's the star formation area, um, and in that, and Orion's Nebula is something that we do look at closer towards, in October and November. Sorry, in November, I would say. Yeah, probably in November. So that's how different it is, and similar to the Saturn Nebula. that we were looking at earlier when we started. Same scenario here as well. The star goes through its cycle. It becomes a red giant, slowly starts shedding off its layers, and then it starts to become highly unstable. And then eventually it'll start pulsating, and the outer layers will eject because of all of the changes that are happening in the star. Um, yeah, I think this. I don't know, Zena. I think this was probably the as far as zoomed as I could get it to be. But
Yeah,
I mean,
yeah, yeah.
there is some details in there for sure.
Oh yeah, no, you can definitely see. You can't really. I mean, from this, just from the stream, you can't really see the star in the middle or the dwarf in the middle.
Yeah.
But it's still, but it makes sense because you said there's two layers of gases, so that kind of makes sense. Probably, even if you were to look at the NASA pictures, probably you won't see it either. I would assume.
You know what? I'm gonna say probably with the NASA pictures they would see it, just because the
Yeah,
Hubble. Yeah, because the Hubble Space Telescope, it's in space, not have to worry about light
fair enough.
pollution and all of that other fun stuff that us Earthlings have to worry about. So so yeah. Um, but you know what? I think what we can try is how about because how about we can try Andromeda Galaxy next, and let's try
Yeah,
that. Yeah.
you know what? We have like what 8 minutes left, so
Yeah, we have time
let's
left. That's okay. It doesn't have to be. We don't have to end right at 11:30. That's fine.
yeah. Let's
But
go
but
to
let's try to see Andromeda because it looked really nice yesterday when Zena, you and I, we were kind of going over the things that we wanted to do, right? So
Yep. Yeah, it was really nice. Yeah, look, I was so impressed because I've imaged Andromeda like the one like through SharpCap at least. Um,
right.
like a while ago, but it was during I think it was in the summer, and the way when I saw it yesterday with you, it looked much better. Like it was the image was more sharp, and I was thinking, well, like I was thinking maybe in wintertime, imaging in wintertime on clear nights, for some reason it's always better, or the images look way better than when we image in summertime on clear nights.
Yeah, I mean, it definitely does help. Like the cooler weather definitely does help with the imaging for sure. Um, and yeah, you're so right. But of course, again, the trade-off, right? It's in the in the summertime we get more clear skies, clear nights. Sorry, but then obviously there's the temperature is quite warm, and that does kind of take away.
Distorts the light.
Yeah, it distorts the light and just take away from like the objects itself. So okay, so we're at Andromeda right now. Let me just quickly make some changes, and we'll try to get there.
And are you gonna go for the center? I'm assuming you're going for the center of Andromeda.
Yeah, so the other thing is obviously Andromeda Galaxy. You won't get the entire galaxy in your field of view. Like Andromeda, if you would have to put Andromeda Galaxy, the entire thing in the field of view, it would cover like 4 or 5 full moons. I think that's what it is. Like maybe even more. Um, and maybe someone can assist me in the chat with that one. If it's like five, if it's like 4 or 5 full moons, like how much it'll cover. So it's quite big, but what we'll be able to see is we'll be able to see a portion of the galaxy. Um, yeah, so I'll try to, and of course, as we go through with the stacking, we'll get more and more clarity in the image, or sorry, more detail in the image. Um, but but yeah, sorry. Let me. Oh, there we go. Sometimes the arrow it gets a bit
Yeah,
finicky.
because Andromeda is close to us. It's our neighbor galaxy.
Yeah, and I think it's only 2.5 million light years, million years away. Only.
2.5 million.
It's just almost like stepping from Vancouver to Calgary. Oh, no, I'm just kidding.
In space language or space terms.
Um, okay, Kyle just said I'm spot on in terms of the full moon reference. So thanks, Kyle. I appreciate that. So yeah, we're definitely getting some detail, and again, I'm sorry the stream is a bit behind, but just bear with me while we're getting more and more detail on Andromeda Galaxy. And maybe for this one we can try to zoom in a little bit. We don't have to do a lot.
No, I don't think so because you're aiming for the center. I think it's.
Yeah. Okay. I'm just gonna revert it back to where it was. Okay. Yeah. Let's keep
Somebody
on
just
going.
said it's also coming towards us. Yep.
Yeah, it is.
No, it is. We are going to collide with Andromeda Galaxy, but that's like in I don't know how many billion years from now. So we're
Yeah.
not gonna see it.
Yeah. I don't know which will come first. The collision with Andromeda or or dying of our star. That would be something for future generations to think about, I think.
Yeah, I don't even know if we're gonna live that long. Like our race or our species, human species.
That's true. Yeah, that's
Unless
very
we
true.
evolve into something else, like humans would evolve into a different kind of species, that maybe.
I mean, maybe humans will evolve into interplanetary travel, if that's what I'm thinking about right now. But that's what's coming to my mind. Maybe they'll evolve to being capable to travel between different planets and different systems. Maybe that's what they can do, and then they'll get a better view of the collision between Andromeda and our Milky Way galaxy. Okay, so yeah, I mean, we're picking up some details, but. How's that looking in the stream?
In the stream, it looks good. It is, yeah, it's like
Yeah,
it's a little bit darker, but I don't. It might be just delayed.
Yeah, I think it's a bit delayed. Zena, you're right. So let's just wait for that. Okay, we're getting there, I think. Sorry, there was just one thing in the chat. There was a comment regarding any plans for the return and in person. Um, there were plans, but of course, with the way things are going right now, that's it. We'll just kind of have to wait and see on how things progress. But as it stands, it'll just be these online sessions that we're doing. But that is something that there's definitely plans for that. But at this time, it's a bit too early to see where it's gonna be. But yeah. So how does it look now in the stream, Zena? Is it any better?
Yeah, it looks it's slightly bluish green. Maybe you can lower the blue.
Oh, okay, sure. Let's.
At least on the stream, it looks like it.
Oh, maybe that's a bit better. I don't know. I did something. We'll wait for it to catch up. Maybe I'm too bright. Maybe I'll just kind of dim the. Okay.
Yeah, it's better. Like now, I think it's.
Yeah. The other thing is the core of the galaxy is quite bright as well, right? Because generally with galaxies, you know, uh, everything at the core is very bright. So that does end up happening as well. But yeah, it's definitely clearing up. So let me just quickly.
It looks good right now the way you have it.
Oh, okay, that's nice.
Yeah, and that's where the black hole is, the center of the galaxy.
Yeah, the center of the galaxy.
Center of every galaxy.
Yeah, absolutely. So yeah, this was Andromeda Galaxy, and I think we're at 11:30 right now. So I mean, anything else, Zena, that you wanted to see or?
I think that's a good way to end it. Like ending it on checking our neighbor and how it's doing as it's coming closer and closer and closer to us.
Yeah, I absolutely agree with you. So I think this will be a good point to end for today. Before we again end again, thank you so much for everyone who was able to attend. Sorry about a bit of the technical issues at the start. And a big thank you for the moderators, Disha, Kyle, Zach, who helped out, and also Haley, who helped out as well. So thanks everyone for your help as well. And then, and of course, Zena, thanks for being my co-host for this time. I'm glad that we were able to get the technical issues out of the way early enough.
I know. And thank you for being the tech person and being so good at it because I know I would not be useful at that. So I appreciate it.
You know what? I'm gonna take this opportunity to give a shout out to Joanna, because I would say she would probably be the one who helped me to figure some things out. So if Joanna is watching or listening, or if she's in the chat, thanks to Joanna for just the tips on how to figure out the audio and the observing part. So yeah, again, thanks everyone.
Awesome. Yeah. Thank you everyone for coming. We look forward to having more clear nights. Keep looking up.
Yeah, absolutely. All right. Thanks everyone again, and have a great night. Take care. Bye.